So you study at Canada?
I did my PhD at the University of Toronto. If you know university, yeah. Mm-hmm. Oh, that's awesome. I hope we can do more. Thanks for letting me know, Guilherme. So Edmar and I am trying to do more stuff together. So hopefully I'll get to visit you guys and talk to more of your students, and hopefully some of your students come here as well.
Yeah, it's great. Yeah. I'm going to USA in September.
Where?
I go to Disney with my kids.
Oh, nice.
So I'm planning to, if possible, I take one day to visit you.
That's awesome. That would be very great.
To them.
Yeah. September is still hot in Texas, but if you can manage to come, please do. Yeah.
When are you planning to go to US, Edmar?
In September.
September?
September 26th.
Really?
Yes.
Me too.
Yeah. Okay.
I'm going to a training in IEEE in New Jersey.
Yes. New Jersey. Oh, nice. Yes. Nice. Yeah.
Great.
Currently, I am the Region 9 Treasury, so I will have a training there.
Okay, nice.
It's a lot of
work. I like New Jersey. Yeah, it is. IEEE is a lot of work.
It's a lot of work.
Which society are you in?
I used to be in the Systems, Men, and Cybernetics Society.
Okay. We're finishing up a journal that we're submitting to the transaction.
The SMC transaction?
Mm-hmm. Yeah.
Excellent.
Great. I am for signal processing and sequencing systems.
Nice. Yeah.
Yes. But now I'm thinking to change because I decided to dedicate my career to cybersecurity.
Okay. That's good.
I'm finished my
all the tools that you know are useful. Yeah, very useful. Yeah.
Edmar, have you already attended the SMC flagship conference?
No.
It's a very nice conference.
Can you send me more details, Vanessa?
Yeah, sure.
When is it? Yeah, like when is the 2024 done or?
No, it happens in October.
Oh, but probably the deadline is over. Yeah.
When Vanessa, when I started to be professor here, the student branch of IEEE was closed. So I opened them and
nice.
I reopened them.
You revived it.
I stayed 10 years.
Okay.
Then the coordinators. Now I'm not anymore.
Oh, but that's nice. Nice. Okay. Let me share my screen.
Okay.
Yes. I'm in charge of us accepting the participants.
Okay. Awesome.
And I think we can start in 3 minutes. Okay?
Yeah. Okay. So I have the infinity mirror just to tease people until everybody's here. And my style usually is interactive. So at any point in time, if you have questions, I'll keep asking if you have questions, but feel free to post questions to the chat. And if you can help me, Vanessa, and pose me at any time if there's a question, because I won't be able to see the chat while presenting.
Okay, I will translate this part for our audience. Pessoal, quem quiser fazer perguntas, pode fazer no chat, que no final ela responde. Tá bom? Eu acho que é mais fácil para vocês até para perguntar escrevendo. Fiquem à vontade.
All right. Should I start?
One moment more, because I need to accept more invitees. Okay, I would like to introduce you first.
Yeah,
okay?
Go ahead.
So, good afternoon, everyone. Boa tarde a todos. we have organized this event to celebrate the IEEE Women in Engineering Day. And it's a pleasure for us to have Dr. Eman here, who is an active volunteer with IEEE. And she is currently serving as the co-chair of the IEEE 5G Security Working Group for the International Network Generation Roadmap. Thank you, Dr. Eman, for accepting our invitation. I would like also to thank the volunteer from the IEEE Women in Engineering UFCG, the Student Affinity Group, and the IEEE Women in Engineering Northeast Brazil Affinity Group, who organized this webinar in a collaboration. And finally, I would like to also thank my colleague, Professor Edmar, for putting me in touch with Dr. Eman and invite him to introduce our speaker for our audience. Edmar, the floor is yours.
Okay, thank you very much. Thank you for everyone to be here. Thank you, Eman, to be here with us. I think that Vanessa has introduced it very well, Dr. Eman. So please, you can present now.
All right, thank you so much. Thank you for hosting me. Thank you for the opportunity to talk to you. As I was telling Vanessa and Edmar, I'm talking to you from the beautiful city of Toronto, spending a few weeks here before going back as the semester starts in the fall. So my name is Eman Hammad. I'm an assistant professor with the University of Texas A&M at College Station. This is like Edmar asked me to talk to you, to provide a general and some motivational talk. So I'll touch on some technical aspects, but some professional aspects as well. So I did my undergrad in the Middle East in Jordan. I'm originally from Palestine. And then I came to the US. I did my master's in electrical engineering, where my thesis was on real-time wireless communication systems. And then I went to Canada, where I studied at the University of Toronto. I did my PhD in the electrical and computer engineering department. During that time, I studied what we call cyber physical systems. And my focus was on one particular example, which is the smart grid or the modern power systems. And within that, I really investigated methods for security by design and resilience by design. After that, I worked in the industry, specifically for a company called PricewaterhouseCoopers, which is a consulting firm. Over there, I was a specialist in industrial and IoT cyber resilience, where I worked with different clients, including utilities, rail operators, manufacturing, etc., telecom operators. And within that capacity, we help them assess emerging technologies, existing technologies, old and new, and the mix of old and new, and look at security from the device level to the system level and all in between. So that was a very, very good experience before coming back to academia as an assistant professor in the computer science department, where I helped build the cybersecurity program at the RELAS campus. It's an academic alliance model at the Texas A&M system. I was affiliated there with a smaller university called Texas A&M Commerce, and then I joined my current position last summer, where I am teaching in the engineering technology department. So as you can see from the pictures, I'm very active with IEEE. I try to promote STEM, cybersecurity, and engineering within different circles, whether it's power systems, communication, 5G, and women in engineering. So I hope this will open the door for more discussions in the future. Oh, and I like dark chocolate. Okay, so as a motivation, if anything, you know that we are in an exciting times. So when you look at the technology and the fact that your phone is doing the job of maybe 20 different devices that existed 20 years ago. It's very, very exciting, especially if you are in the engineering and the technology field. In this slide here, what I have for you is some snapshots from the news within the last couple of months. And what you see here is things that are very exciting, but at the same time raise questions from a cybersecurity perspective. So myself as a professional who have been in the field for 20 plus years, I look at this and I'm like, I hope they built this technology with some serious consideration for the safety of the people who are using the technology, with deeper thinking into what could happen if the technology is not loses integrity or loses availability. So let's we're not going to discuss all the examples, just let's look at a few of them. So Elon Musk, the guy who runs Tesla and SpaceX, he has a company called Neuralink. And Neuralink is it's a chip that can be implanted in the brain, and it can help regulate functions that are not regulated by other means. So it's very exciting. So if you have not heard about the technology, read about it. It's very, very exciting. Now, during the past, so last year in the fall, they started what we call clinical, they applied to start clinical trials, meaning they want to try this technology on actual people. So when you have a chip that's wirelessly connected, that's implanted in the brain, so we call that the the machine-brain interface, this introduces a whole new set of what we call risks, right? What could happen? What are the if statements that we're looking at? How do we mitigate this risk? How do we give the patients or the people who have those plans guarantees that this technology cannot be used in a way that's opposing the actual positive and exciting purpose of that technology? Another one is what everybody probably heard about is all the fiasco that happened when multiple AI scientists and engineers raised flags about generative AI evolution, including Sam Altman from OpenAI before he resigned. And the idea was the main concern or the main risk is when it comes to generative AI and what we call trust in the technology, in the output of the technology, we do not have actual technical tools to say this outcome is more trustworthy than this outcome. And if you have tried ChatGPT or Llama or any of those LLMs, you know that they can be very, very confident while telling absolutely nonsense. So that's another concern. And just to make things a little bit more closer home, nuclear power plants are one of the ways to generate clean energy. Now, in cybersecurity, when we deal with nuclear power plants architecture, network architecture, we are very strict about what is in that architecture, what are the flows of information in and out of the different network segments or zones, because it's a nuclear reactor. So if anything goes wrong, what happens? Like very, very, very serious impacts could happen. Now, people are considering drones inside the core of the reactor. And they are considering autonomous drones, meaning that we're using AI to fly the drone and for the drone to actually detect any defects, try to prompt maintenance requests and all of that stuff. All good stuff, but the risks exist. So when we talk about those exciting scenarios, we have to balance the benefits and the risks, and we have to not evolve the technology faster than we can evolve the security guarantees around the technology. All right. So an analogy that I use when I teach is when you build a house, you can use all the fancy technology that you want in that house, but when you design the house, you have to consider in the design that it should have a security mechanism so people who are living in the house feel safe, right? Okay, so in cybersecurity, we have a term called threat landscape. Threat landscape is what is actually happening, not against my system, but against all systems around me and all systems that are similar to my system. So this is a report from a cybersecurity manufacturer called Splunk. And they describe the trends as following. So we have increased sophistication of threats. What does that mean? It's not a simple attack. It's not somebody who's knocking on somebody's door and doing a denial of service. We have attacks that have multiple steps. And the multiple steps could be tools that are provided even as a service. So we have ransomware as a service right now and stuff like that. At the same time, on the other side, from the protection, like if you are a security engineer, you have those tens of tools that are available to you to be able to defend the system against active threats. But the fact is that those tools are not streamlined, meaning what? You have a hammer and a screwdriver and a nail and all of that stuff, but you have to actually set up each of them, and they do not necessarily work together or can be automated together in an efficient way that makes you confident that it covers all the bases. So on the protection side, the tools are very complex. The stack of tools is complex. You need a tool for XYZ and another tool for ABC, etc. Also, there is a fundamental change on where things are hosted from a computational perspective. So we have the cloud based services, and then even things that as simple as networks, routers and switches, which are physical boxes right now, they end up being in the 5G and 6G era, they end up being virtual functions, meaning what? They're just like a program, a software. They're a software, which makes your job as a security engineer much harder and makes the job of an attacker a little bit easier. At the same time, over the world, because of this evolving technology and evolving threat landscape, there's always need for really good security engineers. So if you're interested in this domain, you are at the right time, at the right place right now. With the advent of generative AI, we're starting to talk about the world of algorithms. You will have an AI against an AI. So an attacker using AI against a system that's using AI to defend that system. All right, so what do I do in my research? In my research, I look at the system view, and I look at all the exciting things that we talked about, like can we distill them into elements and look at those elements, what are the trends, and for each trend, what are the challenges, and how can we leverage the tools, the same components, to actually make the system stronger and more resilient. And I'll talk a little bit about resilience against a disruption, including cyber attacks. So what are the enablers of all those exciting applications that we mentioned a few examples of? We have connectivity. So 5G, us researchers, we already started talking about 6G, where you have holographic applications, you have more streamlined mixed reality applications, vehicle to vehicle and infrastructure interaction, autonomous vehicles interactions, etc. At the same time, we have more integration of systems. And with integration, we mean what? We mean we have system, maybe the vehicles. So if we have all vehicles with connectivity, then we have system, and maybe electrical vehicles, then we connect the electrical vehicles charging with the power system grid, then we are integrating those two different systems together, and that creates some interdependence between those two systems. Whenever we do that, we are coming up with a more complex network because we're connecting two networks together. And interdependence creates this fascinating dynamics where can we guarantee if part of the network fails, it does not impact the other network? Or can we understand if one part fails, what is the impact over the other network? And with this connectivity that we introduce between different networks, we can describe it as it's enabled by Internet of Things, and it's enabled by services, including communication, including networks, etc. And another enabler, which is intelligence in general, machine learning, AI, data-driven models, distributed algorithms, etc. This is just a tool that enables us to automate very complex tasks, because as the system grows larger, its scalability becomes an issue, and some of the analytical methods that we use might hit a limit. All right, so what are the trends? We have more distributed systems, we have more autonomous systems. And autonomous, what do we mean by autonomous? We mean systems that are able to run without human interference. They take decisions, they have their own understanding of the environment, they have defined guidance about what to do. So they have if statements. If it's an autonomous vehicle, it should act as, I can understand all traffic lights. If I see this traffic light, this is what I should do. But it's a little bit more complex than that. So what is the challenge with distributed and autonomous operation from a cyber perspective? We have different entities that are trying to talk at the same time. What's the challenge? The challenge is they have to trust each other, right? So what happens if one entity is actually a rogue entity, meaning it's have bad intentions, and I try to communicate with those autonomous agents? So I have actually a research project going on that. The other challenge is all of you are part of families, right? When you take a decision within a family construct or within a class construct, you try to balance your benefit and the group benefit. So I cannot do something that will harm my family, right? So I have to do something. Maybe I want something that's better for me, but it should also be good for my family. Good for me, but it should also be good for my classroom or for my university or for my students, right? So that's the balance between individual and group benefits, and we do this through mathematical frameworks such as game theory. And the other thing is privacy. How can I coordinate with you without sharing too much information? Right? Okay, the other trend is massive deployment. And within massive deployment, we say, let's imagine one state in the United States, and let's take Texas. Texas is big because I work in Texas. So the number of, if we are to automate to electrify all vehicles, so all vehicles to be electric vehicles, and we are to equip all highways and roads with charging stations. How many charging stations do you think we will have? A lot. Like Texas is big, it's huge. So when we're talking about massive deployments, we're talking about whatever we do, it should scale, and it should scale really well for operations that are time sensitive. So we start talking about mathematical frameworks such as systems of systems, interactions. We start considering the interdependence, and the limitations imposed by one element over the other element. Similarly, we talk about uncertainty, and uncertainty comes from the fact that in cybersecurity, we never have 100% confidence over what an attacker will do, or what the tools would be, or When it will happen, to what extent it will happen, we don't know. So that's a very high level of uncertainty. And that requires us, when we do any innovation, that the innovation that we create or the system itself that we create should have degrees of flexibility that allows it to handle uncertainty. All right. So this is how we abstract. This is what helps me understand any complex network. I can divide that network into 2 layers, the physical layer and then the cyber layer. The physical layer is all the components, if you're in manufacturing, production, industrial, those are the actual motors, PLCs, IoT, sensors, all of those stuff. Power systems, those are the transformers, the relays, transportation, those are the locomotives, the cars. Now, those physical elements interact with the environment. The cyber is the entity that actually transfers the information between those elements below, and it's the same layer where the thinking happens. If I want to take a decision about what the actual motor will do, if it's accelerating or deaccelerating, the cyber is where this thinking happens, because that's where the intelligence, the control systems, the networks, and the exchange of information. And in some instances, we have the operator, the controller, the human in the loop. And those layers, we can abstract that the exchange of information between the physical and the cyber happens through sensing data that's going here. If you see my mouse, to the cyber, and then the cyber thinks and then tells the physical, stop the car, put more voltage or current on the power system, accelerate the conveyor, add more, change the robot dynamics, etc. So I'll pause here for questions. Everything is good?
It's okay.
Okay. So let me talk about a framework for what we mean by trust. So when in engineering and in innovation, when we want to trust a technology, it's not an easy task, because there are different elements within any system. There's the technology part, and that's the easiest part to handle from cybersecurity. Then there's the process, and the process, what we mean by the process is the things that use technology to do something, right? That's bigger than one specific tool. Let me give you an example. So when you cook a meal, that's a process. Cooking a meal is a process. You will use different technologies to do that. So if a robot is cooking a meal, right, they have to get the ingredients, they have to set up blah, 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 etc. So the end-to-end process of having a meal ready, that's a process. It will use multiple technologies. And then there's the element of people, because people are at the front of the technology or at the back of the technology. The technology is to make people happy, or people use the technology to make themselves or other people happy. So how do we trust then? What is an actual metric of trust? This could be security metrics, and those are generally, we define them as availability of the system, integrity of the system. Availability is the system is available when I want it. Integrity, the system functions as I want it to function, as it's built to function. And then confidentiality, the system does not provide information for people who are not allowed to see that information. So that's security. Then reliability. What do you mean by reliability? How is that different than security? Anybody wants to answer? When we say something is reliable,
it will not fail.
Yes, exactly. So you know that when you want something, if your friend is reliable, you know that when you need them, they're there for you, right? So for systems reliability, I want to trust that this system, when I need it, it's operational. So that's reliability, and it's operational in reliability has metrics. So 99.99% reliable, right? So for power systems, that's the reliability metrics are very high. For healthcare, it should be very high, etc. Safety. What do we mean by safety? If I want to interact with a robot, let's imagine ourselves in 10 years or 20 years into the future, and robots are living with humans everywhere, right? That's what people are thinking right now. Do you want to have a meaningful guarantee that when you interact with a robot, you should not be scared that any harm will occur to you? You should, right? Now, when we use some automation or robotics in manufacturing, we usually have like a fencing area around the robot. Why? Because if anything goes wrong, we want to make sure that there are no people in the range of motion that could be hit by the robotic arm, for example. So safety is an element. And then we come to resilience. Resilience, by definition, here. So this will help us understand resilience. Resilience is defined as the ability to anticipate, expect, like you think into the future and you expect disruptions, recover. So before the disruption, you anticipate what will happen. If something happens, you are able to adapt or withstand the disruption, and then you are able to recover from the disruption. So those are the elements that define what resilience is. And if we are to build an analogy with a person, if you fail in an exam, are you able to hold yourself together during that hard time and then study better and recover from your failure afterwards? Now, this is important in cybersecurity, especially for complex networks. Why? Because this is what we mean by building the system with security by design elements. What can we use? We can use so many tools, and here are examples of those tools. Let's use an example. So if you rely on going to school, you're a student and you go to university, and let's say you always go to university using a bicycle, okay? What is your plan B if the bicycle is not there? Do you have two bicycles? If the bicycle is broken, how do you get to school?
Use the second bicycle, or?
So that's redundancy as a resilience. So as a resiliency, if you have two bicycles, you'll use the second bicycle or borrow a bicycle. Or maybe you'll take an Uber if you have an exam, etc. So that's redundancy as a resilience metric. If one component fails, you use a similar another component that can do the same function. But there are other types of resilience. There is something that we call adaptive response. So and you notice this in yourself. So if something is coming at you really quickly, you just dodge it, right? If somebody is trying to hit you, or like you're walking and suddenly you realize there's a bird flowing in your face, you dodge it. So that's adaptive response. In systems, I'll show you a few examples of how we can do that as part of that control loop. Then there's something called deception. So as a resilience mechanism, especially in cybersecurity, we can use deception. So if an attacker is coming to us and intends to manipulate the system in a way for their advantage, what we can do is play with the signals that we provide from the system, so that they are trying to them, they're working to disrupt our system, but what they see is not the reality. Does that make sense? And then there are other three elements that are here: analytic monitoring, contextual awareness, and coordinated protections are advanced methods where we use AI to analyze the events and what we know about the system in real time, to anticipate, like try to predict if there is a failure that's coming in, if there's an intrusion, if there's an anomaly, something is not right. And then we try to understand what is happening and then try to mitigate in an automated manner, reconfiguration of the system. All right, so this is what I do in research. These are some of the projects that I'm working on right now. So Edmar asked me to talk about opportunities at Texas A&M. So if you like these areas of research, talk to me. We'll see. Like, it all depends on funding. So if I have sufficient funding, more than happy to work with some of you. I work on 5G and 6G networks. And within 5G and 6G network, we look at how we can reconfigure the network, how we can use. Remember when I talked about softwareization of security functions? That's what we work on in 5G and 6G networks. I work also on Internet of Things and industrial control systems and operational technology. And within that, we work on process integrity mainly across different things. And we work on digital twins as well. I also work on public safety and critical infrastructure. We like systems like NG 911, where we do security testing and risk assessment. And we work also on things like autonomous vehicles, connected autonomous vehicles, etc. And lastly, we work on human in the loop. We consider things like social engineering frameworks. And social engineering is what an attacker uses. Remember when we said any system is people, process, and technology. So with social engineering, this is what an attacker targets on the people. People think, and in a very unique way, they react in a different way. So they try to manipulate people's reactions and thinking and reflexes to get them to do something that they shouldn't be doing. So we just finished a 2-year study on that, and we're working on a journal. We also look at digital well-being in interacting with technologies. Those are some of the things that I'm working on. All right, I'll pause here and we can discuss. Then I'll talk about some examples, but those are very technical. So let's pause here. We're halfway through, so any questions?
We have in the chat a comment and a question from Guilherme. He says, here in Brazil, there are many points with free Wi-Fi connections, which makes me think, how easy it's for someone to get my information just by connecting my phone or computing, sharing the same Wi-Fi network. He wants to know about how secure is share Wi-Fi network.
So wireless security is a tricky topic. My advice when you're in a free Wi-Fi coverage area is do not do any critical functions, like do not do online banking, do not log into systems, do not do any of those things where you have login information and sensitive information. And if you have to, then you have to use a VPN client, a virtual private network client. That's number one. Number two, always double check the Wi-Fi that you're connecting to. Is it the legitimate wireless access point? And you can ask if it's in a cafe, if it's in a mall, you can ask and double check that this is the actual one. It's not a fake one that somebody is providing. So those are the two main things. And the last thing is always configure your Wi-Fi connectivity to have security handshake mechanisms. So things like security protocols, for meaning that your traffic will be encrypted between you and the access point. So some things like WPA and stuff like that.
Lucas, you can ask.
Lucas, I think that you have a problem with your audio. Please write in the chat.
Emma,
Any other questions?
I have a question while Lucas is typing his question. I have a question about the aspect of ethics.
Ethics, yes. Excellent
Yes.
question. Yes. I'm bringing this back because of ethics. So, what is the question? Like, do you want to frame the question?
Actually, I want to know how in US, currently, how is the status of the discussion about ethics in the use of AI tools?
Yeah. So this is a very, very difficult question. And this is the cause of, remember when I said at the beginning, some of the AI experts are raising red flags about where we are and where we can be in a few years. So 2 years ago, there was an AI bot, which is like when you open a website, an automated agent talks to you, right? So there was an AI bot that somebody with some mental illness was talking to for a couple of months. And the AI agent convinced the person to commit suicide to join her in the digital realm. Right? So ethically, who is responsible if an AI convinces a human to commit suicide? Is it the people who came up with the AI agent? Is it the person, like who's responsible? This is somebody who was killed by an AI.
It's a complex question. Oh my gosh.
It's very difficult. It's very difficult. And what makes it more difficult is, in general, when we deal with technology, like if somebody makes a medicine, there's a trial, clinical trials before the medicine is approved for human consumption, right? So there's so many things that a pharmaceutical company has to go through, so many gateways before they can say this drug is, let me go to this thing, trust, before they prove this is safe for use, right? For AI, nobody's doing that. Nobody. There was a news article 2 months ago. So OpenAI now have a library. That's the company that came up with ChatGPT. So they have a library that's able to clone the voice of anybody. So they can record my voice, listen to my voice, I think, for a few seconds, and they can say anything using exactly my voice. They realized that if they release this technology, it will be very dangerous. So they did not release it. But they did not say they will never release it. They said they will not release it now. So the ethical question is, why did they even develop that technology? What is a good use case for a technology that clones somebody's voice? Mm-hmm. Right? So we call it responsible innovation. Like when you actually create something, like do you think about if this is useful or not useful? Like what's the purpose, right?
Sometimes you have technology, but you discover how it will be used when it is in application.
Yeah. So I have So we have a small project. Let me go back to the projects that we're doing. So we have a project here called, I didn't list it. So I work with a psychology professor, and we published a paper already on ethical guidelines for when you create an application. When students in universities, do they have enough information and knowledge and training to say when they create and design a project, like when you do your graduation project or capstone project, when you do the design and the planning, do you consider ethical questions? Do you consider psychological questions? And what we did with that is with that study, we looked at computer science students and we asked them, those are some of the guidelines about ethics, like, do you consider unintended consequences, which are what we're talking about right now, Vanessa? Like, this application was created to do one, but it can be abused and used for XYZ, right? Do you actually think about how it can be abused for other purposes? So that's also something that we're looking at, but it's a very difficult question. I think we make it difficult because the companies that create the technology, they're looking for money. Money is always the problem. And if you think about how you use some of the games and some of the apps that you use, it was shown that the big tech companies actually use manipulative algorithms to get you to spend more time on your device because that's more money for them. How ethical is that?
Mm-hmm.
Right? Yeah.
Good question.
Yeah.
I have a question from Lucas. Lucas says, I'd like to know what you think about the current security of IoT devices.
Very good question, Lucas. This is why we do research on it. There are two types of IoT devices. There's the consumer IoT devices. Those are the things that you use at home, like your camera, your coffee maker, your fridge, whatever you have at home, and it's like smart. These are consumer level. In general, for consumer level IoT, security is not great. Why? Because if they want to add security, they have the companies. It will make the product more expensive, but they're selling it to you very cheap. So they cannot afford like really fancy security mechanisms. So it's a cost issue, right? So for most consumer technologies, the security is either weak or does not exist. The other type of IoT devices are the ones that we used on operations in industry. So these are like the commercial levels, like surveillance cameras for traffic, for example, or for security. RFID sensors, infrared sensors for military applications. Those have much better security. It can be improved, but they already have like good or better security because of laws and regulations and because of where these things are applied. Nonetheless, some of the IoT devices that are used in health, in cars, they have been proven to have serious vulnerabilities. And you can look at the news and you will see every week, you will see something about a vulnerability in an IoT device. So the short answer is it's not great. It's not good.
Any other question? Edmar, would you like to comment something? I think Lucas again. No, Lucas Justino. You can ask Lucas.
Are you listening to me or you?
Good. Go ahead, Lucas.
Regarding the weakest link spot, like one of the most common way of invading some asset, are there like countermeasures to protect one asset to another, like internal in a company, in an environment, like the attack was made, it has access to some of the information. Mm-hmm. Is there countermeasures to protect another information of another area, like internal? If you understand.
Yeah, I understand. So this is where we talk about security by design. So let me show you one example. Yeah, here. So this is what you see on the slide is like, this is a 5G network, and you will have multiple parts of the system, like the network. So a basic good practice in networks, when you have like large network is to divide the network into parts, so that if one part is attacked, the other parts are protected. And usually you have firewalls between them. So if you look here inside this box, you have 3 different layers for the same network, and then we have firewalls between those layers to protect and filter the traffic that's going between them. Similarly, we have algorithms and functions where we can actually isolate network flows, so we can implement like more security functions over critical flows. For example, if it's sensitive information, we can implement more security over this, as opposed to maybe web traffic for streaming. So there are things that can be done to mitigate the risk.
Perfect. Thank you, Professor.
Of course.
We have one more question from Guilherme. Guilherme, go ahead.
Oh, hello, Professor. Can you understand?
Yes, I can hear you. I can understand.
I typed a question, but I would like to update it. Like, the AI cannot learn by itself, but having all the informations on the internet, how dangerous it can become for us, or for an enterprise, or someone?
I didn't get the question. Can you repeat it?
Like an AI, artificial intelligence, it cannot learn by itself. Like,
yes.
It cannot study or something like this. How dangerous it is when we put it in the internet connection, like connected to the internet, and having the access of all the informations we can put there, like Facebook or research, historical research or something like this.
Yeah, a very good question. Just give me a second. So,
okay.
Just give me a second. I have to walk my son to the bathroom. I'll give you 2 things that happened in the last 2 years. So with LLMs, with large language models that are largely generative AI, right? One company, the engineers were using the technology to help them with the programming, to improve their code. Okay? So what they did is, when they used the technology, they put parts of their code into the ChatGPT-like program, and they asked it to help them fix the code, and that worked. After a couple of weeks, somebody else from outside the company, so that the company is Samsung, somebody outside the company was looking to fix their code, and ChatGPT provided an example, which was Samsung code, right? And Samsung code is protected by intellectual property. So it is very dangerous. This is why now, after they first came up with ChatGPT, which is trained over everybody's information, right? And they said, okay, we can give companies or people who are concerned the choice. So if you go to ChatGPT now, there's a choice where you can actually engage with the large language model, but contain your information. Your information is not used to train the model. So I don't know. I don't have guarantees 100% that if you actually choose that this will actually happen. They say it happens, but we all have question marks about how they're doing it, right? The other part of your question is most of the applications that we interact with are owned by very few companies, right? And you mentioned some of the companies, Facebook, Meta, Google, etc. What people are doing is trying to diversify the tools. So if you're using an email from this company, you do not use a chat, like an app from, you use another app for maybe social media that's not owned by the same company. Why? So that not all your information, not all your behavior, not all your everything about you is in one tech company, big tech company. Does that answer your question?
Yeah, sure. It's like the security would be opened to different companies and different codes. So even if they access one of them, the other ones will be secured by the other ones, right?
That's the hope, but it's not necessarily true. Because,
okay.
Because it happened actually to me. So you go to an app from Google and you try to search you're trying to do shopping, right?
Mm-hmm.
And then on Facebook, you get an ad for the same thing.
Yeah, it's kind of complicated.
So what happened there? So it's not necessarily true. I think they have their own sharing between them, and that's obvious for money reasons, right?
Mm-hmm. There's a game I use it to play called League of Legends. They have a protection called Valorant. I think the Valorant is problematic. I stopped playing because of it. It always has a screenshot about your computer. Mm-hmm. You know when it is coming. You don't see it happening, but they say it's because they use for protection against hackers or stuff like this in their game.
Yeah.
But when it comes from an enterprise that you don't know their applications or what they want from you, you cannot know that if they are taking more information from you, unless you have the control.
Yeah, and nobody reads the license agreement. Nobody reads the consent form. Like maybe it's in the consent form, but even what's in the consent form, it's written in a way that's not helpful usually, right? So you have like this legal jargon, and like, okay, tell me what I need to know. So for me, when I go to any website, there's usually a question about cookies. Do you want to accept all cookies? So what do you do when you get that question?
Yeah, you just accept no, I don't accept, but there's places you cannot just say no. So you're not going there.
So it's actually there is. So they give you like a very big click button that says accept all cookies. But if you look, there will be a link in smaller font or something below it that says let's see all options or confirm my choices. Then if you go to that, you're able to adjust the cookies.
Oh.
But they do it in a way that's deceptive, right? It's much easier for you to accept all cookies and go because you will be like, okay, it's just like, it's harmless. But for me, I usually spend the extra 2 minutes to find that option because by law, they have to provide that option right now.
It's like the bottom two close ads.
Glenn, sorry to interrupt you, but I think that your questions are very good, but we are almost
running out of time.
Okay, thanks, Professor.
Yeah, of course. And feel free to reach out to me. I'm on LinkedIn, and I think my email, I can put my email in the chat, or Vanessa can share my email. Okay. So let me talk about a few examples of how we design systems with resilience in mind. So this is my lab. This is what I have in my lab setup. So let's look at one example of a complex network. And this is what you see. If you're electrical engineering, you should know what's on the right side. What's on the right side here is an electrical single line diagram, right? So this is generators, buses, and loads. If you don't, that's fine. So the arrow is a load, the circle is a generator, and the lines that connect them are transmission lines, the lines that you see between towers, electric towers. So we take this network and we said, let's consider what will happen as a cyber physical disruption. What could happen and how can we improve the system ability to anticipate, withstand, right, adapt, and recover from a disruption. And the disruption could be what? A disruption could be an event that happens in the cyber layer or an event that happens in the physical layer. Or something that can happen in the cyber and the physical at the same time. And we consider advanced targeted attacks. And if that happens, it could be on the IoT, it could be on the sensor, it could be on the communication topology, it could be on the load, it could be on the generator. What's our success criteria? How do we know that the system is resilient or maintained, was able to successfully mitigate what happened? We define that the system is stable in the case of power systems. And we implement multiple algorithms. What you see on the lower left, if you did take control courses, is the output for a controller, the input for a controller, and that input for the controller is actually a function of the state and the communication, the cyber layer. So we can adapt to the system if the communication is lost in between agents, like the active components of the system. We can compensate by trying to control parts of the system and make sure that this part is stable. So that's one way of using by design how we can change the communication links and communication flows and local elements such as energy storage and sensors to make sure that the system remains stable if there's something that will target the cyber layer or if there's something that will target the physical layer. And what we're trying to do is trying to make a security that does not impact operation. So the system still has a very good performance, but at the same time is resilient. So what you see in the table below is sometimes resilience will impact performance. And sometimes you will have the best performance, but you will have zero resilience. And that's when you have centralized controllers. So one single point of failure. And if that point goes, then the system is down. But we show in the bottom two rows, we can come up with really creative ways of having a good trade-off. So we still have good performance and at the same time we have acceptable resilience. If something bad happens, the system operates maybe not optimally, but in a very good operational point. This is another research area where we say, okay, can I also, remember we talked about different ways to improve resilience of a system. Can I make the system adaptive to the level of uncertainty that comes with cyber attacks? So the answer is yes, we can do that as long as we can actually derive a metric that reflects the uncertainty and we are able to put that metric as part of the cyber physical operation. This is another example, and here, if you have studied networks, there is something called software-defined networks, and that's the core technology that's used in 5G and 6G. With that, you can buy software, tell the network what to do and how to move the information, what information to move, etc. So in this research, what we said is, let's take a cyber physical system, that system that has the controllers and we have the cyber, and we said if one part of the network has higher risk, then let's try to move the information in a path that has more security relative to the other paths through the network. But at the same time, we want a path that is able to provide the performance. Remember, we're working in real-time operations and stability is the main concern. So what in optimization language, we're trying to do multi-constrained optimization. So we're trying to do a quality of service plus security, and those usually are contradicting objectives. This is another example. This is for microgrid networks, where we are able to handle uncertainty, autonomy, resilience, and adaptive capacity. We use all those elements to move a distribution network to be a self-healing system of systems. Let's look at another example. This is the 5G example. This is an example from something that we do in my lab, which is what we call cyber range. A cyber range is a system where you as a student can log in and try different things. within a cybersecurity course or a cyber physical course. And this is one setup. This is our cyber range 2.0. Now we have 3.0. And what we're doing is we have AI in the loop where we study, we want to study, we didn't implement it yet, but courses are running on this infrastructure and they are able to do their own labs, but we analyze how they're doing the labs and how they are learning to be good cybersecurity professionals. So that's another area of research that we're doing. I'll pause here. I think we're done. So we'll spare a few minutes for last questions.
Okay, so thank you, Eman. Sorry, Vanessa, to interrupt you. That you had a good discussion before, but I'd like to just highlight some points that I take notes.
Yeah, of course. Go ahead, Edmar.
The first one is about IEEE. What society you are connected to?
Communication society and power and engineering societies.
Okay.
Two. Yeah.
Okay, good. I was thinking about when you said technology is the easiest part of cybersecurity. It's an interesting affirmation.
Yeah.
Okay, but I think that I agree with you. For me, the worst part is people. The worst part is people. Also, I'd like to highlight you that some projects that you are developing are near of projects that you are developing here at UFCG. For example, we are interested in operational technology, cybersecurity operation technology is one of the main points that you work in here. And finally, from my side, I think that our students are eager to understand how can you go to Texas and work with Eman? How can you?
Yeah, of course. Yeah.
Could you talk with some possibilities or?
Yeah. So I think there's a Fulbright program. A Fulbright program is a competitive program, but it's a program where you can come. You're funded for 1 year or 2 years or 6 months. It depends on what part of the program. And you're able to come do a research, maybe summer research or 1 year, or maybe like it funds you for the first 2 years of your PhD or your master's, and then we can find the funding to complete your degree here. So that's one of the ways. If you're Texas A&M has like very strong graduate program, so I can accept students on through the ECE department or the multidisciplinary department. I have affiliations with computer engineering, electrical engineering, multidisciplinary engineering, and engineering technology. So you can do a master's or a PhD in any of those. It depends on the available funding that I have. But if you're interested, send me your resume, send me what you're doing. And to prepare you to do graduate and research, start working with your professors now, see if they have some research, small research projects. Get familiar with what research is, because it's not the same thing as like courses. Do your own small projects and build that into your resume. So if you have one paper or one report, that will help you a lot, whether working with me or working with other professors. It shows that you actually did some research and you're able to do more.
Okay, thank you, Eman. Very good, very good. I think I can ask you if someone has some question.
I'm putting my email, so you feel free to reach out to me. One thing is try to mention in your email make the subject line very descriptive, so it doesn't go with other filters.
Okay, so
and I'm working with Dr. Edmar, so if we get any funding, I think you'll be able to work on a project between the two of us, between Texas A&M and your university.
We discussed there is an open possibility now. We'll discuss it with you. And maybe you can send some students to you.
Yeah.
Okay, thank you. Vanessa, do you have some more to add?
No, it's okay for me. Thank you, Emma, for your presentation. And thank you
so
all
much.
for attending this event.
Okay, so thank you, Eman. Thank you all that you were
Okay,
very fast.
awesome.
I hope that next time you come to Campina Grande to stay some days with us.
Yes,
In person. Next time in person.
I hope so too. I hope so too. All right.
Bye.
Be safe.
Thank you.
Thank you.
Bye.
Thank you all. Bye-bye.
Thanks, everyone. Bye-bye.